pleasure for us to be here with you. Thank you for being here in this session. We're going to be talking about climate change and its relation to development and the impact it has regarding the energy mix and the energy sector of the countries. And one of the things that it's important when we discuss is it that seems to be that there is a dichotomy and
y el cambio climático, la lucha contra el cambio climático.
and actually it's not that we consider that there are no trade-offs, but it seems to be that we need to identify, to minimize and accompany the countries so they can achieve their goals, both in the commitment and the development of their climate commitment, so to say. So we consider that what we need is a more comprehensive approach of these two phenomena, development and climate change, but at the same time we need an approach that is specific enough so that we have the particularity of every country. Because you know that climate change is a global phenomenon and the impact it has in every country depends basically on the resources that every country has in the productive matrix, and the energy sector does not escape that logic, even if there are some things that are very common and cross-cutting for all of the countries, and we can expect that the temperature increase might also cause some climate changes, some problems with the grids. It is true that the impact in a generation, for example, depend on the form, the shape, infrastructure of every country. So it's necessary at the same time not to have not only a comprehensive but also specialized approach. And from the World Bank, we started to manage and create some reports called CCDRs, Country Climate and Development Reports. Mariana will be talking about that. And the idea is that they need to identify actions and prioritize them to accompany the countries in the joint achievement of economic development without compromising their environment. That is, helping in the reduction of the greenhouse effect gases and the adaptation. This is what we are going to be discussing, and then we are going to zoom in the impact of climate change in the generation of the southern cone. And this will be discussed by Florencia and Luciano Caratori. So I will introduce them. Mariana Contegran has a PhD from the UCLA. She is a senior economist and sustainable development of the World Bank. She is a professor at SEMA. She has received many Fulbright scholarships for investigation and research. She has published in many journals, such as Journal of Benefit Cost Analysis, Economics Indicators, and many others. She was involved in this role as an economist in the World Bank in the creation of many of the CCDRs I was telling you about. For this Zoom, I was telling you about the climate change and the economy. We have Florencia and Luciana Caratori, who will talk about an interesting work they have done. Florencia has a master's degree in economy from the UBA, specialized in energy, renewable energy in Spain. She specialized, as I said, in the World Bank for the countries of the southern region, Argentina, Uruguay, and Paraguay. She has worked before as an advisor in the public sector. Also in the public sector, she has worked in many projects. And Luciano Caratore is an independent advisor focused in climate change. He works in Caratel organization. He has worked in the public sector as well. She worked in the Senate of the Nations. He was Secretary of Energy at the National Office of Climate Change, in Argentina Action Plan for Energy and Climate Change as well. And he worked in the plan of Argentina. He was the Secretariat of Climate Change. He teaches in many master's degree, Flaxo, UBA, and some other University of Argentina. He has also published many papers on climate change and economy. So without further ado, I will leave the floor to them so they can present their points of views. Good afternoon. I would like to thank the organizers for the invitation and the bank that wanted to have this event to show you the results, as Julita was saying, of these CCDR reports. These are country reports on climate and development. Do you have a clicker to change the slides? Let's organize this way. So basically, to help you see when we have the end, I organized this presentation around 10 questions. And you can see here those lines. These are the groups of questions that relate to the same topic. First, I'm going to tell you a little bit about these country reports, what it's in there, which countries have received that, and then we're going into the relation between energy and greenhouse effect gases emission. And then we are going to see deeper what we see in the CCDRs regarding the energy system and the recommendations that have been drawn from these reports, and how we see that we will be able to help us in the activity that the World Bank, together with the countries, to improve some dimensions of that interrelation. So why CCDRs? We, as bank, have a plan, an action plan for climate change for 2025 that is similar to what was being said by the colleague from NADB in the previous panel, and what we propose is to advance in the funds that are dedicated and invested by the countries and their activities and analysis, but mostly in the money that is being lent, so that in 2025 most of that money has to be related to climate change. In fiscal year 2022, 41% of the money that was allocated by the bank was already destined to climate change. So it was right on the way to accomplish this goal. So what is included in the CCDR? They are diagnosis. So what they do is the following. For every country, they view everything that there is, everything that is an evidence. So in that sense, this is a IPCC report in small scale. So what they do is see the evidence of climate change in every one of the areas in the whole world. We cannot say this is something so big, but what we do is that actually we see the evidence first to see what's written, which kind of papers there are in some of the countries. And then the final goal of the report is to see how the countries can increase their resilience to climate change and also to adapt to the decarbonization that is being projected to the world, seeing the challenges that this decarbonization poses, but also the opportunities that they may bring. So the report has 4 parts. All of the reports in the whole world have 4 parts. One is reviewing the literature of impacts, and then we see the institutional framework, if there is a law on climate change, what kind of data we have, if they're digitalized, if they are published, if they are available, how they're organized regarding the discussion around climate change, if there is an interministerial council, like in the case of some countries. Then, in chapter number 3, we analyze the sectors. So we see energy, water, mining, and all of the sectors. What are the policies, if they take climate change into consideration or not? And in some studies, what we see is there are some gaps where there are no studies being done. And then we go and do a specific research. And chapter number 4 is macroeconomy. That is, seeing how the climate policies of adaptation or mitigation, and some that are a combination, because we were talking about this before we started with the panel, because there are some adaptation actions that are also include mitigation. For example, maybe in a square I can have some trees and I can have net so I can catch water, and that's good because I'm gonna be there under the shadow, but I'm mitigating because the tree is capturing carbon. So we see all of that together in detail, but in chapter 4, what we do is we see how these policies and everything that relates to climate change have an impact in the microeconomy of the country, and if they have an impact on poverty or distribution. Oftentimes, the countries, and in the region we have many, the countries have models where we can have the cost of the policies and see the impacts on the economy. And these are the kind of models that we review and that we use in the report.
Now, which are the countries with CCDRs? I'm already on question 3. The countries with CCDR are all those that appear in the graph. To talk about our region, we start with Argentina. Argentina's was the first one together with the one from Peru. They were presented the same day in December 2022. And then we have Brazil, Colombia, Honduras. And now we have others that are quite underway, like Paraguay, the one from Dominican Republic, Ecuador, and so on. And throughout time, we will be able to cover most of the countries with this sort of reports. Now, by the end of this year, when we go to the COP, I'm not going to be there, unfortunately. I would have liked to, but when all the institutions go to the COP, you'll see in this graph that we will have encompassed not only a lot of countries, but also emissions more than 50% and the global GDP around 61%. So we will have served a lot of cases because each country is its own case. They have a specific geography, specific population, specific economic structure, and so even though there are things in common, there are specific characteristics. So, what were we talking about before? Climate change and economy, but also the energy sector, have a relationship of back and forth, as I say. Because climate change affects economy, but the economy afterwards takes revenge, and climate change becomes stronger. So there is an animation. I think that it will appear soon. There we go. So regarding the impact of climate change in the energy sector, my colleagues will speak about that afterwards. For this specific case, they will present. I'm going to talk about the other side, how the energy sector has an impact in the emissions of greenhouse gases and what can be done with that. There's going to be challenges, opportunities, and that's what I'm going to be talking about. And my colleagues will deal with the second part. So, this is not news for most of you who are following these topics, but what I wanted to show you is that the case of Latin America is particular in the sense that the percentage of greenhouse gas emissions that is related to the energy sector is considerably lower than the percentage worldwide. And that happens because agriculture, livestock, all the things, all the activities that have to do with agriculture are very important in the region. The green bars, so the dark green and light green, this is bigger than in the rest of the world. That doesn't happen elsewhere. And so in that sense, that is a bit of a relief because there's lots of emissions associated with energy, but we can also blame these other sectors. One more? No, let's go back. But the situation is different. Well, Latin America is not all the same. There are many differences, and what I wanted to show you in this slide is precisely that. Uruguay, for example, and Paraguay, even less of the percentage of greenhouse gas emissions has to do with energy, precisely because of the energy mix of those countries that uses a lot of hydropower. And so that's why their emissions are lower, and that's something that we can clearly see in the graph. Mexico is a different case. In their case, the exports are quite big, and so Latin America has big differences. This is quite obvious, but this graph shows it in a clear way. And when we go to the policies in the CCDRs in the energy sector, where do emissions come from? And even though there are differences among countries, what we see there is that transport is very important. Taking the case of Paraguay, what happens is that transport is essentially done with fossil fuels, and so we see a very high percentage, but the energy mix is very clean. So that's you shouldn't worry about that in particular. So I'm already in number 6. Which things are looked at for the energy sector in the CCDRs? So apart from the impacts, what we see, what we look at, is basically thinking about whether decarbonization is happening, if the objectives of Paris are being achieved, what should you have, and it's not just for all gases net zero emissions. It's net zero for carbon. The other gases, for example methane, that was being talked about in the previous panel, have to be stabilized. We don't need them to be net zero in 2030. So we know that for that temperature there are associated emissions that are these ones, and we know that net zero for carbon has to be fast, and that methane and the other ones have to be lowered, but they don't need to be zero. And so we know that that objective of temperature has an emissions objective, but that emissions objective goes hand in hand with a certain distribution in the generation of energy, right? So this basically, to provide you with an image, these are the scenarios of the IEA, and let's compare it with the current situation of distribution of energy between oil, renewables, coal, and what we should have in the most ambitious scenario, which is the last one, so with net zero in 2050. And what you see first is the percentage that needs to be generated with renewables, and it's a lot. And on the other hand, the natural gas and oil bar is lower, and also, of course, the coal one. And so in the next slide, this is basically what we'll look at in each CCDR. So we go into the energy sector and we see, okay, what happens with the supply, what is the energy mix like, the electricity grid. We take a look at the fees, the energy efficiency, that, as someone well said in the morning, is another energy resource. I'm sure, Andrea, you really enjoyed that phrase. And so we also take a look at that, and we take a look at the critical minerals as well, because critical minerals are very associated to the demand for energy, and so we also take a look at that in these reports. Okay, you can't see anything here. That's Flora's fault, because she wanted to have matrix, well, we have all the CCDRs in the different dimensions, which is renewables, oil and gas, energy efficiency, and critical minerals. So, Flor, I'm going to give you 5 minutes less. So, I'm going to tell you a bit about the case of Argentina, which is the CCDR that I participated the most in. But in Argentina, what did we do? We took a look at the renewables, the previous regulations, we saw the potential, these maps where you see that there is a lot of wind in the south of the country, a lot of sun in the north. And we drafted some recommendations based on that. With oil and gas, the same. We took a look at different possible scenarios for decarbonization. We saw opportunities in terms of generation of income, but also the challenges if there is a lower demand in the future, and that could lead to some issues, and so we created a model for that. In energy efficiency with Lucia and her team of energy, what we did was take the results of a work that was done where we looked at different options for energy efficiency, and so which ones implied an increase in activity, increased jobs, and lower emissions. And we saw that the triple advantage was not present in all of them, but yes, in several of them. And then, regarding critical minerals, in the case of Argentina, it's copper and lithium, and we checked the advantages and disadvantages, the income for lithium, that we had to be careful with the social and environmental impacts, and so on and so forth. Okay, I'm in number 8. So, I wanted to talk especially about mining in relation with energy, because it's one of the topics where the region has a lot of potential. If you look at this graph, what you'll see is the participation in the world of the reservoirs of critical minerals and the production. And perhaps I could digress regarding critical minerals. They are critical for different countries. Some minerals that are critical for some countries are not critical for others, because this level of how critical they are is determined on whether it's important in the economy, but also in the security of supply of those resources. So maybe a mineral could be critical for the European Union and not, and that could not be. Maybe it's not the case for the U.S. So if you take a look at the highest bars, we have copper and lithium. That sort of determines if in another country it's another mineral. We take a look at the other minerals. But for example, in Peru, Chile, Argentina, well, not in Chile because we don't have a CCDR, but in Peru and Argentina, we would take a look at the biggest reservoirs that the country has. So what do we see here? We see that Latin America has enormous reserves. Chile, for example, has a high percentage of the copper reservoirs, also of lithium. And the ones that have figures are the countries for which we have data from the Geological Service of the US. The other ones, even though it's not reported in detail, also have these resources, so they can also develop them. So what happens with this? In this CCDRs, we always associate the future demand that there can be associated to energy. And here, for example, we also have from the International Economic Association that for solar, wind, electric vehicles, batteries, and electricity grids, we see which are the minerals that are needed. And so you see that lithium and copper are needed. The lithium market is much smaller, that's why the bars are much smaller, because in volume it's much less for lithium than for copper. So according to the projections, we expect a big demand, big growth in demand for copper and lithium. Of course, if we have an energy transition. If the energy transition does not happen, this will also impact mining because we also won't need as many critical minerals. And on the right down there, it's a bit small, but you see in gray lines historically what has been the growth rate, and this is for copper. And what we see there is that historically it has had this movement, but the projections in red are for the net zero scenario. So the increase that we would have in the growth of copper if we had the demand for energy would be really big and more than the historical value. So we wouldn't have a historical comparison for that. The lithium is not as much as copper, but okay.
So I'm concluding here. These CCDRs, each of them based on evidence, they say what kind of things could happen. What could the country do if they did something? What would be the result? So of course I cannot tell you everything we have done for every country, we can tell for every one of those, but this graph shows the type of conclusion that was drawn regarding the solutions we give. And with these arrows, we show what relates to energy. So the amount of policies and recommendations are not recommendations, but only scenarios. If this happens, then this would happen. So always energy is there, mostly regarding decarbonization and of the generation. And finally, to wrap up, this is something that I added, something that is very important that we do as well, is that I told you that we see the effects of policy on poverty, but I didn't tell you much about that. Also, we talk about distribution. I couldn't tell you because we didn't have infinite time, but we see the employment market. What are the sectors if the world is really decarbonized? Which sectors would have less employment and which sectors would have more employment? So that is a dimension that we also analyze. And regarding financing, in all CCDRs there are estimates of the investments we need, and in case if this is possible, which investments are more feasible to be done from the private sector or from the public sector. And these are some figures. For example, for the countries that are relatively richer with per capita income that are a little bit higher, we have here Argentina. It should be an investment of 1 or 2% of the GDP of a year to be able to invest towards climate affairs. Maybe investing to improve electric distribution and these kind of aspects. And countries that are relatively poorer, this is a higher figure because they have done less, so that's why it's more. So finally, to conclude, these diagnoses take a lot of work. It's around 1 year of a group of people's work. We hire also people to do specific things for these reports, but the bank does this with three main goals. One is to help in this discussion between climate and development. The idea of these reports, the message we transmit, is that the climate policies are not the enemies of growth, that is, the growth of the GDP, or development, that is, considering the three pillars, not only growth, but also the social dimension in all of its aspects. And of course, it's not an enemy of nature, because that's the reason why they're done. So the idea is to be in that discussion with the governments to point out that there are opportunities too in making climate policies. Then, something that we also do is to support the countries when they're doing their NDC in technical matters, for example, because this CCDR is an analytical piece of work. We have figures, we model, it's not an opinion piece of work. So the technical staff from the World Bank oftentimes can support with technical measures and affairs in the long term strategy towards carbon neutrality. And on the other hand, also supported with analyticals the loans. The bank, I don't know if this is approved, but it has a credit for Uruguay with a reduction of the associated rate that is, as I said, associated to methane on kilogram of live flesh or meat. So Uruguay has a mix of indicators, and this is one of those. So having created CCDR in a previous study in the case of Uruguay, we do not have one, but we're about to start one. It helps us to stop thinking about how the methane emissions are in the country because we have a diagnostic done before, so we can implement this faster, these kind of innovative solutions. So I hope this was interesting to you, that you have an interest now in the CCDR. You have them published in the website at world level, and there is also a summarized report of the findings of all countries. The first one is on the website, and the second one, it's going to be published soon. So go please and read them if you want to know about this product. Thank you very much. Well, now basically what we're going to do is a double click on what is related to the impact of climate change in the framework as a piece of work we developed in 2021 or 22 together with Olade. Here we have Fabio Garcia. We would like to thank him. He also participated in the team. So we worked with this research with the World Bank together with Luciano Caratori as an advisor and an advisory team that did the research on the electric system of the Universidad de la República from Uruguay and Tecnalia, a Spanish company that created the simulation scenarios for the climate. So this was a very big team to be able to complete this piece of work. So the idea and the content of this presentation is to introduce and present the results of the study, the division of the climate analysis, and especially what we see in the impact of the electric systems of the southern cone countries. And this study focuses in Argentina, Uruguay, and Paraguay. And as a last topic to be mentioned, we wanted to talk about the conclusions and the main related recommendations. And why did we analyze this and why did we start to think that this study was relevant? Basically because of what has been talked in a previous session regarding natural gas. We observed during 2020 and 2021 a stark reduction in the rainfall of the Rio de la Plata basin and the Patagonia basin. And this could also have an effect on very complicated situations. For example, when there are effects on the atmosphere such as El Niño and La Niña, and they could be also linked to starting to see the impact of the climate change, and that this situation could be repeated in frequency and intensity in the future. And that is the reason why we have these projections of the intergovernment panels of climate change that do not highlight that the effects of the droughts or floods could be more intense or not from 2030 on. The bank, together with Olada, decided to do a research for Argentina, Uruguay, and Paraguay to analyze this impact on the electric systems at regional level and also individually for every country. So the goals are to assess these impacts, assess the impact of climate change expected for 2050. What do we mean by this? What we're going to do is that we're going to verify the conditions of the climate and the atmosphere of what could be seen in the future, that is, forecasting the climate possibilities for 2050 and to understand how the electric system of the countries for 2030 could respond to those conditions that could be verified for 2050. Also, one of the goals was to understand the impact in individual terms in the technology of generation, in hydropower, wind power, solar power, and thermal power as well, and biogas and biodiesel. Also understanding the impact in costs and the flow of electric exchange in the region as a reaction to these electric systems in the future climate changes. And as we are projecting and try to understand how this offer behaves, we also try to understand the demand, and this is going to be related to all of the projections of the increase of temperature. That is how all of the projections of the demand change. And finally, there are recommendations on how to reduce the vulnerability of the electric systems to climate change. Just for you to have a scheme on what that is, in this research, the time frame is 2050. The climate change that could be verified in 2050, as I said, on the electric systems of 2030, and what is used to project these climate variables are both scenarios of concentration of emissions, RCP 8.5 and 4.5 of the Intergovernmental Panels of Climate Change. In the assessment section of the climate change, Luciano will explain that further. We already talked about this analysis, and the idea is that this focuses in Argentina, Uruguay, and Paraguay. We included Brazil because of its relevance in terms of the interconnections and its influence in the hydropower generation of the region. So even if the conclusions are in these countries, Brazil is also included in the analysis. What are the variables that we analyze to link climate with the electric system? Well, we analyze the changes in rainfall and the maximum and minimum temperatures, the flows, mid flows, radiation, and the speed of the wind. And also, what are the impacted variables? This relates to impact of the demand, evaluation of technologies, the costs of supply, how the exchanges of electricity may change at international, regional level, and everything that could be verified in case of the hydropower being increased. This summarizes the points we analyzed, the sites. These were relevant to analyze the electric behavior of the countries and to get weather information, historical observation of the climate variables we already mentioned, to then further on with the climate models. We could do a projection, and they worked as a base to correct many of the theories that we have used with other sources of information on the climate information. And these are the places we analyzed, and they also were useful to adapt the analysis. How were they modeled? Argentina was divided into two, Paraguay and Uruguay was modeled together, and Brazil was divided into four regions because of its relevance and because of how it's actually interconnected with the mixes, energy mixes, and technology of generation. The temperature in this study was evaluated to understand the impact on demand, on the thermal generation, solar generation, and wind generation. Rainfall will also have an impact on the evolution of the flows and the hydropower as well, and the speed of the wind and solar radiation on wind generation and PV, respectively.
Here we can also see the number of places that are considered that are the affluents of the electrical centrals that were studied in the areas of interest of the study. As we said, the region of Comaue and the basin of the Rio de la Plata. So you see the relevance of Brazil for the area of study of this work. Now, Luciana will continue with the methodology. Thank you. So, summarizing, because Florencia has already gone over this is the scheme of how we constructed the scenarios up to 2050 or 2030, climate change in 2050, which is the most complex thing to communicate based on the relationship between the climate variables. We are talking about 60 years of that approximately, and the relationship with the different flows. This was worked with neural networks, and there's a relationship with electricity systems. We are going to see the exercise now. This historical link between the different variables, where this was analyzed with two trajectories of concentration according to the fifth report of the IPCC. When we finished with this, we didn't have the sixth one yet, which has additional data, but apparently the conclusions would be the same on the basis of the trajectories that are representative of concentration and how they would affect these variables. We created the projections that were mentioned before, and 9 models were fed based on those two trajectories for concentration, 4.5 and 8.5. So this gives us 19 scenarios, 2 trajectories, 9 models each, plus the baseline, and those 19 scenarios, the behavior of these variables, end up feeding a simulation model of the electricity system that Florencia is going to describe afterwards. On the basis of the integration of these variables and the systems of energy of the region, we got these technical and economical results that Florencia was mentioning and that we're going to describe later. It's also interesting to understand what we didn't do. This is not an optimization exercise. It is an exercise that, I'm starting from the third point, but this is an exercise that takes the configuration of the energy systems of the countries to the year 2030 on the basis of the official documentation and the official scenarios provided by the governments of the countries. So we're talking about publications and official exercises. In this sense, it's not an optimization of the expansion, but how that configuration would react to those changes that could occur in those variables, not something else. This is important because with a stimulus, the governments could react by, for example, redesigning their systems, taking into account the results of similar exercises. The exercises that we're carrying out are exclusively focused on long-term changes that have to do with the chronic physical risks. So we're talking about increase in temperature, increase in precipitations, and all of these are the focuses of the exercise, as well as other things that occur in the long term. We are not talking about heat waves here or other things that could also be an object of analysis regarding adapting to climate change, as Mariana was saying earlier. So it doesn't pick up substitutions of demand. So we don't have hydrogen, for example, as a source. It sort of follows the trend. We expect no big disruptions in supply until 2030, and it doesn't include economic results. So when we talk about more expensive or cheaper or the impact of exchanges, this doesn't include the considerations of the countries that transcend this. I'm referring to discussions like from the one in the previous panel, such as natural gas, biomass. This is the structure of the capacity that is installed for generation up to the year 2030 based on the results of the countries. They come from the expansion plans of the countries. Here, I should clarify that where it says thermal, electrical, thermal, that includes all thermal. So biomass as well, nuclear, not just fossil thermal energy. And the basis of this mix is where we start to produce or simulate the different changes of the variables. So going back to the trajectories that represent the concentration, so what they show, these trajectories are different concentrations of greenhouse gases in the atmosphere. The RCPs, which are those trajectories that I was mentioning before, show, in a broad sense, the results that could come from said concentration in the atmosphere in a certain point. We chose 4.5 and 8.5. 4.5 is a stabilization, an intermediate stabilization of the concentration in the atmosphere, which so we are talking about an increase in global temperature, something of a certain amount. This scenario is quite optimistic, and then 8.5 would be leading us to an increase in temperature above 2.5 degrees. But to talk about the conclusions, I would like to call out the level of uncertainty of these things. So each of these colors, what they're marking is a trajectory, so a certain range of concentration of greenhouse gases. This is the result of application of these different models, as was said before. And the same trajectory can have several emissions associated, and this is also reflected in the change in temperature resulting from those trajectories that represent the concentration. The blue that we see down here is 2.6, so it's below what we were seeing before. And we are talking from 0 degrees to 1.5 degrees of increase of temperature in comparison with the pre-industrial area. And then 8.5 means 2, and 4.5 or 5 degrees. So naturally, this will impact the variables that we carry out when we analyze the impact of those variables in the electricity system. We're going to have a huge range of results. However, we have some common elements in those results that give us an idea of where the thing could be headed independently from the models. So in all cases, climate change in 2050, according to these trajectories and taking into account that there is another important challenge, which is the geography aspect. These are global models that are done, and then you have to do a downscaling in order to have a better resolution. And that, of course, is another stage which also has an error range. But for the region, maximum temperature and minimum temperature increases according to the two trajectories and models of each one, and that rain, or the variation in rain, is quite heterogeneous. In some regions we will see an increment, in others we will see a reduction, or we'll show it now in the dissemination of the results of the application of the models. And so these variations in rain, of course, affects the flow of rivers. Not just that, but also variability of hydro energy, which of course also has an impact in hydroelectric energy. And what we are showing is precisely that, both for the average flow, which is the first set of graphs. When it's red, it diminishes. When it's blue, it increases. For a quantile of 25, and this is what we're going to see in the simulation of hydroelectric energy. So here I don't have the axis. What we see here is the dispersion of the average daily temperatures according to these 9 models applied to the two trajectories. This is an average of variation of all the points that we analyzed that we showed before, which doesn't mean this average could have some cases in which it increases or decreases, taking into account, as I said before, that it is heterogeneous. So we see that for the trajectory of 8.5, they are above the ones for 4.5, which is quite aligned with intuition and what we see in graphs generally. And it shows increases of temperature between 0.7 and 2.4 degrees for the year 2050 in these scenarios. Regarding rain, it is a bit more difficult to reach a conclusion. There is a lot of uncertainty. What I want to point out here is that we have changes here, for example, for different models applied to the same trajectory. Some models in the region are showing an increase of rain, of the daily rain as an average, and others are showing a decrease. And there is a clear differentiation between 4.5 and 8.5, as we saw before. The little cross there shows the mean, and there you could see some differences. Similarly, with solar radiation, what is observed is that 4.5 has more dispersion. This doesn't mean that geographically it could have maybe bigger differences. In both cases, most of the results show values that are below the baseline. So you see it's -10 downwards. And then we have the wind speeds, which also show results that in some cases are higher, but then Florencia is going to explain the effect of the change of temperature as well and how it could affect generation. Florencia? I was going to ask for the microphone. So what we're going to analyze now is the impact of these scenarios and climate variables on how the generation systems work and how they behave. The tool that we use is SimSay, which is a platform that simulates the energy generation system, and so it allows us to simulate operation of the system and also allows for planning of investments and incorporation of technology. This is the methodology, a bit of the procedure that was carried out. I think that part of it is understood. We said, okay, we'll take the flows, temperatures, climate variables, speed of wind, and initially we configure an electrical system for the base year. Then we introduce the effects of climate change. We calibrate the simulation system of the electricity system, and with the effects and the models, hydro models, we run a simulation of the system based on 2030, where we include the projection plans and the expansion plans of the of the countries, and this gives us the behavior of the technologies. I'm going to just go through this very fast. These are the behaviors for technology, and so what is shown here is how the basins were modeled for the different uh, hydroelectrical centrals, where we calculate the increments of each central and we take away the natural flow, which would be without the effects of human action, let's say, the series of natural flows of the hydroelectric plants, which are upstream in the same river, because many times they share the flow between different centrals. And so that way we can identify the increases of the hydroelectrical centrals. This is an example of how temperature has an incidence on electricity demand. Here, the model, the graph, what it shows is the average power per week that is demanded in Uruguay and how it varies when temperature is modified by 3 degrees.
And in summer, the demand of electricity increases, and in winter, it's way less. One of the assumptions that was also to be considered is how the electric centrals are affected by temperature, and we assumed it is reduced 1% of efficiency and 5% the capacity of generation of the power centrals, and we have a turbine of 256 megas, and also how the temperature affects PV, and we know that the temperature and its increase makes the generation less efficient. And the assumption is that this is reduced in zero point 0.4 in the generation for every degree that is increased. And also with the temperature and the capacity of generation of the windmills or turbines. This is the configuration of the electric system. Here we see the interaction among the regions we already mentioned before. They're incorporated in the simulation. We see the northern part of Brazil and northwest was modeled, but it was outside the scope of this research. So we see here the summary and the most important part of that. And we see here in the rows the most important variables that are modeled and affecting the countries. I believe that to be simple, the way would be to read the effects as a whole and to explain a little bit the information regarding the increases that are opposed to the decreases of the base scenario. And in the colors, we can see the intensity of the effect. In the three countries, and when you analyze Brazil, we expect an increase of the demand related to the increase of the temperature that will also be related to the demand of Paraguay that has a bigger effect than in Argentina. The hydropower generation and the median of this and the 19 scenarios that is projected, and this is a chart that is summarizing once again. This is not a conclusion, and it's not highlighting any probability of occurrence. It only assesses all of the 19 models, and it shows the median of all of the scenarios with a base case. But this could also happen in the 19 models we assessed. In this context, we can see that the increase of the rainfall that happened in Brazil had a positive effect downwards to Paraguay, where you can see that the increase of this is positive in Uruguay. In the map that Luciano already showed us, there is an effect of the rainfall, and thus the hydropower that is analyzed could decrease. What is related to the wind power and solar power generation is shown in what Luciano showed. It's sometimes more, sometimes less. And what we draw from this is, in general, what the models are presenting. In the case of Argentina, the Comahue region, that is the most important for wind generation, has a decrease of the capacity for generation, and the opposite happens with the PV zone. In Uruguay, the decrease of the hydropower generation is compensated by the wind power generation. The thermal self administered energy, we see here a decrease in all of the cases. Altogether, this happens because of the expectations in the country having a hydroelectric power. We see less available power because there's going to be more water that can act in the moments in which this is a base and it is multiplied by the level of activity. So we have a power that is available and that also affects the thermal self-administered power. Here we have two results for the base thermal one in Brazil because of the same result, because of the capacity of generating this electricity. In the case of Argentina, what we see here and relates to what has been discussed in the previous panel is that we see that most of technologies increase, and then of course this is more important in a thermoelectrical point of view, and also because this acts considering a longer term of changes in the generation of renewables, and this could also be make everything softer, not such big movements. And this is a study that optimizes the administration and thus bigger hydropower generation in the region. So it's not necessary to turn on this high technology central plants. And the cost for supply of these centrals also decreases because of the same reason. Here what we wanted to show you, Luciano, did you want to add something on the graph? In the conclusions? Okay. Here we see the relevance of the exchanges. We were thinking that Argentina in the previous graph had less availability in electricity, and in average the international exchanges show that Argentina is going to export less to Brazil. Brazil will export occasionally more to Argentina, and the exchanges between Paraguay and Argentina will be more relevant because of the increase of the hydropower that is the effect of more rainfall in Brazil. And it shows that the relevance of the regional interconnections play an important role when climate change starts to have a different effect at regional and technological level. So to conclude, the impact of climate change is highly heterogeneous. Not only does it affect differently the technologies, but also geographically speaking. So we have the projection of the increase of the wind power. Some countries have more solar panel, some other countries have less. So this is not heterogeneous in the region, and it would include in the hydropower with more availability of water. And in regional terms, this availability of water would have a positive impact in the extra materials to go into the turbine, and this would imply a technology with less costs, of lower costs. This would also affect the capacity of thermal generation and also the wind and solar panel in a lesser degree. We could also see that the wind power in some countries such as Uruguay might be increased, but in some other countries, in Argentina, that's not the case. And in general terms, the PV solar energy could be affected by the temperature. Also, the impact of temperature will also be there for the demand, and we will be able to understand how this is also an instrument for mitigation of the impacts that act on demand, because the electric systems don't need to have this heterogeneous impact, and what they need is the variability of these flows and of the generation will allow more flexibility in the system. In that sense, as a conclusion, the integration at regional level plays a very important role. I don't know if I can tell something here, yes? Along this line, when we analyze the analysis of this report, what we see is that in the short term, there is more variability of hydropower. This also has an impact of El Nino. This change is increased in frequency and depth because of the climate change, mostly in the midterm or short run as well. This also implies that one of the biggest problems is the pluriannual variation of hydropower, more than what we can see in a year or in these levels of aggregation. And this is very important and brings many challenges, what we see in Colombia with this variability in the increase. And sometimes we see how this thermal situation increases, the thermal energy increases. It's important how we see these results, and beyond the average increasing or decreasing and how much it was for every model. This is an issue. This is not an issue that has been included in the planning of every country in the region. So one of the conclusions we have is that for good or bad, we need to discuss this, not waiting for this to increase or decrease, but we need to bear in mind that the incorporation of this in the criteria increases the resilience, and this is for me one of the most interesting conclusion that goes beyond this. Yes, the uncertainty, how to plan with a bigger uncertainty, because these models show this variability from one side and the other. You were going to say two things. Yeah, well, but you distracted me. Well, basically that's it. That's what I wanted to say. I believe we spoke a lot, very often with the team, and we always reach this conclusion. If one is positive, one is negative, then you need to incorporate that at least to make decisions that might not be optimal, but they're going to be robust. That's what I wanted to say. Well, thank you very much. Do you have any question? Good afternoon. Thank you very much. This has been a very interesting piece of work. I would like to thank Fabio as well. I come from a place where there is a lot of climate change. Honduras is class zero regarding climate change in Latin America. I believe you would agree with me. And at the same time, we are interconnected with 3 countries. And we are the only country in Latin America that has 30 connections, with 3 connections with Honduras, Salvador, and Guatemala. From the academia, from the academy, we have analyzed the Colombian phenomenon and also El Nino and everything that relates to the hydropower. Yes, you reached that conclusion. It seems to be evident, but you need to prove that. And talking about the real solution beyond the models that we could have here with the uncertainty and the likelihood and so on, last summer we had a problem with the firm power. We are interconnected with 3 countries, and they just closed their gates, their doors. And yes, we will have a decrease in hydropower, and I will participate in a market, so to say, because actually you have to survive. Do whatever you can. El Salvador closed their doors, Guatemala as well, and we had blackouts of 120 megawatts. Seeing that scenario, what we went through, we plan for next summer because El Nino is not going to leave in the coming 3 years. It's going to be there. And we're also trying to buy fossil power. Costa Rica already did that very fast. And we have prices that have increased in the region. That's impossible to pay. So all of the things are input for the future that we may see. Thank you. Regarding this, the work that you do, the value of the integration, that is also highlighted, and also the challenges. If it's pluriannual, this variation, that means you have a lot of installed capacity. Maybe you have it for 2 years, and you would have to pay that, and this is not serving at all. So this would have to be a joint work in the region. We read that this was highlighted by the International Energy Agency.
I put this graph, and if within the three countries, Argentina, the base for thermal is incremented a bit due to having this safeguard with pluriannual variations, which is the axis of the job and so of the work, and so hydroelectrical and all the other ones that we analyze, even though on average in the analyzed years we could see that hydroelectrical increased, the thermal is still has a role due to these things. So perhaps the issue, the difficulty of compensating with the regional integration is harder for small countries that are clustered together, because climate change, I give the example of that since climate is a system, how temperature changes and rains change it's like a waterbed. It goes up in some places and down in others. Now, if the interconnected countries are very small, there is little variability, and so it affects them all at once. In that sense, the countries of Mercosur are in better shape because Argentina, well, Uruguay and Paraguay are relatively small, but not as small as the countries of Central America in surface, and so they have more possibilities of, due to interconnection, to have other situations. Right, so the red areas is where it rains less, and the blue is where there's going to be more rain, and so there are possibilities of the effect not being the same for everyone and complementarity to increase. Anyone else? Ruben, if you want, you can give your opinion. He's another one of the consultants that have participated. He should answer. Well, congratulations for the work. It's fantastic. 2 questions. Have you considered grid congestion as part of the work? And if you could provide a perspective, well, the scenario that we see in 2030 is a scenario where we will see more hydro energy, photovoltaic. I understand that in hydraulic as well in some period, but if you could give us some information, that would be great. Ruben, no, I'm kidding. But congestions are taken into account. Now the dumping of the other ones now, it's considered in the dispatch of the country, so that's how we consider those limitants. So it's the 500 or 230 grids, the same as the dispatches now have the programming. Now, regarding dumping, that is not considered. But since the system is interconnected and the operations are optimized this way, with certain restrictions to the exchanges, I don't know if that's clear. That was clear in the presentation, but there isn't an interconnection. Supposing that we are suddenly our friends and we have this exchange, we are reflecting the current status. That's the reality. And what I wanted to say is that in that reality, the dumpings are what we are placing best. So Brazil is exporting that excess, Argentina as well. So with the current commercial attitude, we are placing the dumpings because they are easily placed in the market. This is more of a request. Is there a possibility of where the models of the southern cone are, and academically the ADB also has studies? Could we have a homogeneous room in Sensei to work on this, to continue working on this, because we are going to continue to have new challenges such as hydrogen that is going to bring this new generation. Also the expansion plans continue to change, and being able to update this study since it's been modeled with the whole southern cone. This is just a request if the Sensei room would be available. I think that there was no issue with that. What we have to be aware of is that it's given the status of that study and the database has changed, so yes, it should be updated. With that, I think that with that disclaimer, yes, and climate change results also change, so everything changes. Yes, but even using the same periods, the climate series are also updated. And this use data of R5, and now we have R6, but hello, good afternoon. My question is from ignorance of the climate part, but as a citizen, the image that I had about the future was that Uruguay was headed towards a subtropicalization, and so it's going to rain more and it's going to be warmer. People who work on climate change have told us this in a way. It's the first time that I find a study that says the opposite. There will be warmer temperatures, but it will rain less. It's raining less in Uruguay, right? It rains less. No? The question is, in Uruguay. So this is flows. Maybe we could put another graph. Rains or temperature? Well, the thing is that if you look at it without being an expert in meteorology, of course I am an environmental economist, but if you look at all the temperature projections, everything rises. That graph shows it correctly. No one can doubt that temperature is going to rise in projections, but it will rise more in Paraguay, for example, than what it is foreseen to increase in Uruguay. But rain are really complicated. They go up, down. So the graph of rain is very complex. But the idea is that there will be more extreme phenomenons and that they will be more frequent. But if you look at the trend, yes, it's different from the graph. Nationally or locally, because one of the big challenges of these models is what we call downscaling. You have a bad resolution, so in order to see what's happening in that point. So my point of view beyond what the results say is that we don't know. And precisely because we don't know is why we should prepare to have more robust systems in order to face these scenarios. And just to clarify, how do we change the slide? Okay, so basically what the other graph shows, the map, is that X. That X is the mean of the dispersion of all the models. And so you see red and it seems like it's raining less, but it can rain much more or much less. That's what we're trying to show, that the graph or the map that you're seeing the X, which is the median of all the models. But it can be different. So that's the way which we thought of to show some of the results, because if not, it was 19 times all the variables times 19, so you weren't able to conclude anything. But that doesn't mean that it is what we expect, and as I was saying, it's not a probability of it happening, it's the median of everything that we can see. So we have no microphone. That's what I was talking about, a water bed. It's not that it's going to rain more everywhere. Sorry, there is no microphone, so I can't hear what is being said. Never say never. No, and just to finish, what can also happen is that it could rain less, but when it rains a lot more in terms of millimeters, and so that also affects. Right, thank you. First of all, I would like to say something obvious, but that hasn't been said, and that this is an extraordinary work, and there is a lot of quality in the people involved, the methodology, all the knowledge that has been put into this, but also because of the transparency. You say these are the limitations, these are the hypotheses, this is questionable, this is more firm, and I think that that has an extraordinary value, and that this is just a starting point of a process or a line of work that we will have to work further on. Now, there are some things, when you take a look at the assessment reports, you see that there's topics that with all the doubts that we have, and when you take a look at the models, you start to see clear trends with different variables, different things related to access to water, agriculture in different parts of the world. My vision is that here we don't have this. Clearly, there isn't a clear trend where we can say here it's very likely for this to happen. We can say that only with temperature. No, I'm just saying that we can only affirm that these graphs give us a clear direction for a temperature. That's the only thing. Right. But yes, but it's still positive, right? So what can be the lessons learned now of what we have to keep on doing? I think that's the question. And let's see if you agree with what I'm thinking about. In theory, this is for us to answer two questions. The first one is if we can move forward strongly with a matrix of interaction of hydraulics, if there is space for that, or if we see a red flag there that says, no, not this path, because it's going to be more and more complicated. I don't see that red flag. I want to say that clearly. I don't see, and that's the first question. One thing that you said at the beginning is that you take a constant system, now you don't give the system the chance to respond. If you see that the generation fell 10% less, you put 10% more parks. That is a simple operation that can be done, which in times that are zero compared to the variation times. And so I see no red flag in the sense of saying this can't be corrected in time. So this seems to work. But in reality, systems have to adapt and readapt based on what ends up happening. And I think that that is a conclusion that from my point of view is very important. Now, if we take a step further, what we can say is clearly what I see in that graph in those graphs is left, for example, in the case of Uruguay, where in theory some things will increment, others will decrease. As long as I have the possibility of having more wind or solar, where we have a lot of unused potential, I can handle those differences, and it's something that is completely under control. It doesn't seem impossible. Actually, what we know in our region is that we have a lot of variability in climate. We know that we can have intra-year variations. And of course, there was a lot of effect with the phenomenon of El Niño or La Niña. But the variability that we're seeing here is not something that we can't handle. Our systems can handle that. And if we end up increasing some things in order to compensate that, I would say that the conclusion is that here we have no issues with that. That's my vision. I don't know if you share it with me.
So are you gonna answer that, Mauricio? I have a question and a vision that is different from his. May I? You're always interrupting me. It's amazing. And regarding the first topic, regarding uncertainty, it's the same we have at global level. Everything that we showed before is related to the concentration applied to different models. It is way easier to know what can happen at global level than getting to know what's going to happen in Montevideo because of something that's related to the resolution of the models and the compensations. So in that sense, my point of view is that I cannot see that as a major deficit compared to the scope of the models we have available for this resolution at geographical level, as I said before. Regarding the management of the sixth evaluation report, as you were mentioning, this sixth report, what it says is that El Niño or La Niña will be the first driver of variability of the hydropower in the region in short term, but also increase because of its frequency and depth because of climate change. The impact of this is that not necessarily the variability will be the same that we have been seeing, but it could be more in terms of frequency. That is, I have more years of drought and also of depth. That means there will be less hydropower, and we are not prepared to do so without losing money. That is, who's going to pay this extra capacity so we can use batteries or thermal energy and so on. And finally, on that same line, because of what we have emphasized in this limitation, that is, I'm taking the system you told me you would have in 2030, I'm inventing something because we had a degree of freedom. If you tell me there's another system, I could believe that actually. So the conclusion for me, and I believe we share that, is the one you have. This is not a problem if we manage that. To manage that, we need to incorporate this as variables for the energy planning of the region and for dialogue among countries to improve the integration and respond to those challenges. And that's it. 30 seconds just to say something. What I want to mention is that the variability that already exists, that's what I wanted to say. Look at what happened in Uruguay. We had the worst drought in 100 years, and it was managed. We had a problem with drinking water, but we could handle the energy sector. Well, we have the capacity to manage properly all of this. We learned how to do this. But this report is not just for Uruguay. Yeah, but what I can say is that it's possible. Yes, since the report talks about the pluriannual variations, of course, in extreme events, we could have problems that it could be flooding or it could be a drought, but of course, the effect of the climate change in those variations are not outside the period that is analyzed of what has happened and has been managed. Did I say that correctly, Ruben? Only one detail of what you have said before. I wanted to highlight something, saying that the ENSO sign is changing. That affects the variability. And I believe that this is that we have said, and also the payment for this capacity. I didn't understand that very well. Karatori, I have more doubts than answers and certainties. Here in the study, if we talk about average, we're talking about the scenarios. Actually, not the average, but the median of the scenarios. And when I see this from the point of view of energy planning, I would see the worst case scenario, not the median of the scenarios from the planning point of view, because I say 50% of the cases, if it's good, then and what happens with the rest? So, what I want to say is that if we see the climate change as a problem that becomes an impact in an extreme event, I cannot decrease the risk of the extreme event saying that I'm going to analyze what happens in the middle. So even if this scenario, and I also agree with my friend Caratori here, when what Luciano was saying, so if I'm going to have Niño and La Niña, that they're going to be worse and worse. From the point of view of the energy planning, I would see this in the decision making point of view. I would have a minimum regret criteria. And I would see the worst case scenario and I would think, is the system prepared to deal with this? So you're saying that the southern cone has interconnections that will help me soften the impact of all of this. But I believe that in the end, the problem is who's going to pay. In the variability, we're going to have more renewables or more solar panel. That has also consequences. Who's going to pay that? The same thing happens in the thermal energy, but most of that is installed. So I'm going to use that less in some specific cases. But if I have to fill Uruguay of wind parks so that every year I have to use it, this is something that cannot be managed. This is not as simple as that. I know this is not for the emergency. This is just to have a base energy, but not for the energy because this is not manageable. So a quick reaction. This is not a stress analysis. Actually, this has been done before related to the values of adjusted values, but that's not the goal of the research. We have already discussed it with you before. This is something that should be incorporated with the planning of the countries. What is the worst case scenario? When am I going to fund this? But we're seeing here the big pictures, trying to see where everything is heading towards, trying to see if the variable is so big that if we have these situations, then we will need to adopt methodologies of decision making that are robust when facing this. That's why we are also talking always about robust. So when we talk about this discussion, we shouldn't go faster with the conclusion. So we have more hydropower, that's it, we don't do anything, we're great. No, I agree with you. We need to be careful because it's not that we're just doing fine. We have a problem and we need to see how we're going to solve this in an extreme case. And of course, the highlight of what we're saying is the uncertainty. This was always the highlight of everything. Yeah, but it's more or less that. Well, I'm sorry to tell you this. Because we're simulating everything, but when the values, maybe you're not showing this, of how much the cost of energy was. I have the values. They are in the report with bands of probability. So we're not seeing catastrophic events. You're telling me that 10% is going to increase in the cost of energy, for example. No microphone. That's why in some scenarios we would have to administrate that base. So that scenario is so last year we sold to Brazil our offers with the prices, and if the price is not included in the compensation you want, this is a problem with the offer. So it was already paid for. Well, congratulations. Great study. I agree with Mauricio. So in many CCDRs, what we do is what you said. We take the model and the scenario that's gonna be hotter, the hottest and the driest, and the ones that are gonna be the coldest. And we combine rainfall and temperature with the driest or with the one that has more rainfall. But what we do in this work is, someone said this is a first step, but this is very complete, and you might be able to do something like that, a stress test in the future. Something along the lines of what Roman was saying, and having done all of these studies with the colleagues of Olade in Central America, in the Andean region. I'm interpreting here the art of navigating into the uncertainty that comes from everywhere. And the answers we can get in a study like this, in a pluriannual study, shows us how we have these kind of tools. I think we have these tools already. What concerns me, also in the long run, because of another study we did, for example, planning a regional interconnection, assuming that the complementarity is always going to be constant. And one of the problems of the study we did is that climate change, with its extreme effect, would also compromise the complementarity of wind energy. So we are trusting this complementarity and that the climate change will not destroy that. That was the conclusion. This is in the long run. But I think that in short term, that concerns me because I don't have so many answers at hand. We're seeing this already in this kind of study. Gives us the tools, you might know that, and it's complicated, to see this variability for 2070, for example, and the type of response regarding the management of hydroelectric power. We haven't developed that yet. So this is the aspect that I have as an impression, this information of the research. Of course, it's good because we have more for the long run, more integration and so on. But for this very short point of view, I believe we're not as ready as managers of the system. Without any doubt, we can improve things. But I'm going to give you technical details of how it's done. I think it's worth to say the long-term models we have here. These are the 18 models that I said. They have all of the weather and climate variables in the long run with this. Climate variables, and somehow these models show us how everything changes. With these weather variables, and also the history of the production of wind in all of these places that have been pointed out there, and also solar radiation, the technology team transformed all of the scheduling to keep this correlation in the climate change for 2050. So the possible changes in the correlation among them are considered if these 18 models capture with the state of the art of what someone knows if we know what's going to be the wind in 2050 and the radiation, we created stochastic models that we used later, and this administration has already been done. This is not done for every day, but this is done with a scheduling and the discrimination of wind energy and solar energy. So the changes of the correlations with the complementarity are also considered. We could improve that, of course. That's great that you explained that, but we don't know what would be the tipping point when it arrives in terms of frequency and extremes. But of course, we're going to open the Pandora box. We need to use new tools. So this uncertainty is what we need to manage and we need to navigate.
I hope that the models are going to continue to improve. Thank you, Fernando Ceballos from the Agency for Development. 3 brief questions because everything you've done is very interesting. First, on the macroeconomical aspect of this CDR, have you taken into account the limits of debt of certain countries, perhaps not so much in Latin America but Africa, in order to finance everything that is related to climate change? And the second question, which is sort of a provoking one. You said that there is an opportunity for growth in climate change. In France, there was a very advanced analysis for that, and in order to respect the 2030 objectives, you would lose some of that. And something specific on this analysis that you carried out when you have to make decisions, when we have to go to the tax authority to talk about assigning resources, or will policymakers how will they be able to use your conclusions that are quite uncertain? So how would you be able to make decisions based on that? Well, I'll answer both questions. The first two. In the macro models at the bank, there are several macro models which are used for these things, but in some cases we develop macro models for the countries. I'm going to talk about, for example, the case of the model that we developed for Uruguay. So there we have a model of general and dynamic balance, and what we do is take a look at the capex and capex of each possible measure, thinking that the measures in general in the countries, and it is the case of Uruguay, some are conditional, some have the condition of getting financing, and some are unconditional. And so we test the unconditional ones that, in theory, don't require external financing. And so, knowing this, afterwards you see in the model that has a matrix behind it of consumption and product, what is the pivot product. And so I'll tell you about the results of some measures in Uruguay. It doesn't always say that you win with all measures. In Uruguay, it said that small investments had a positive impact in the GDP in the long run, even though in the short term there was a decrease, because part of the measures had to do with importing supplies, and that doesn't have a very positive income in the economy because you are getting into debt. But with the savings and then the impact of the investment in the rest of the sectors, there is a positive impact. But when you have very expensive measures, for example in electromobility, the impact was not positive. What we say is that there are opportunities. It doesn't mean that everything is an opportunity. There are things that are challenges. And I'll put another example. For example, the commercial restrictions associated to commerce. You can say it is a disaster, but for companies that are sustainable, perhaps it is an opportunity because they will win over other companies in the world that don't have that possibility. However, in the summary report of the CCDR, you will see that in some countries it's -1, -2% of the GDP, the impact in a package of policies, and in others it's positive. But in many circumstances it is positive. And the second question, I kind of got lost a bit with everything I said. Okay, so in financing, the thing is that, as we say there, the poorer you are, the more money you need actually. You still haven't, because you still haven't carried out other climate policies. Financing globally is an issue because if you follow the Paris negotiations, one of the things that was foreseen is that in 2020, the countries in development had to put $100 million for climate policies, and now that didn't happen, and now it is for 2025. Now, even though that's true, it is also true that there is a gap because we estimate that you need around $1 trillion of investment. Sorry, $1 billion of investments, and there's been less than a billion for now, and so there is a gap. You cannot deny that there is a financing gap. But there are also finance innovations that have given good results lately, such as the sovereign bonds that Uruguay has won, or, well, in Argentina, there's also a lot of experience with that, or credits for multilaterals, as I said before, from the World Bank with um, decreasing the fee due to green behavior, and so there is a gap in financing, but there's also options. If you have projects that are proven to be green in the long run, you will probably get something to finance them. Regarding the third one point of view that a lot of policymakers, very renowned policymakers, sustain is that I think that that is not the result. The thing is that there is uncertainty and it has to be included in our planning process. And when there is more and better information, this can be a part of the models for the decisions taken, for example, for the decisions of expansion in those visions that are the long-term scenarios. You can consider that you have exposure to that you could have handled based on the experience that we have by putting money on it. It does have a cost. It has to be contemplated, and so we think that it should be part of the planning process. Adapting to climate change has to be part of the planning process. The adaptation agenda that came out of COP27 and that is being updated this year proposes as one of the 2030 investigation adaptation outcomes to incorporate the dimension of resilience and adaptation in the energy planning of the countries. And when we have better information, we will be better to take other decisions. This is sort of still quite uncertain, but as we learn, we can incorporate that in order to make better decisions. I think that that is the conclusion. It won't go up or down. I wouldn't dare say anyone that something is going to increase or decrease given the state of the art of models nationally, given the low resolution of those models. I don't know what you think, Flor. Yes, I was going to say the same. It is something that you have as a resource for planning, and this tries to add on the discussion that energy planning doesn't just have to be national. We can contribute this in order to have a bit of a more regional perspective of energy planning. Afterwards, it can happen that in moments of stress of the systems, it can be complicated to comply with it, but I think that what this work shows is first that without being quick to jump to conclusions, I think that there is no red alarm yet, and we have to run. I think that there is a lot of uncertainty. We have to consider that, but we also need to take this into consideration as a region. I think that that could be the end of the session. If not, we're going to miss our flight. it was Medardo's fault for changing the time that we were going to begin the event.